So just read this and try it. Always remember, a straight line, no matter how it's drawn, like if you have a straight line like that, it measures 180 degrees. Okay. From one end to the other end, it would be 180 degrees. Right? It's a straight line property. So if you were to split this, but you're splitting it, all right? And if I told you that this is 30 degrees, then this must be 150, right? Like these two add up to 180 because they're along that straight line, straight angle, right? So two angles that are supplementary, right? That's what supplementary stands for. Angles add up to 180 degrees. Right? So go supplementary, arrow to that little definition, just a reminder, right? Supplementary means two or more angles that would add up to 180 degrees. In this particular instance, they give you an angle outside the triangle, but it's strategic, right? It's very strategic. You see that this is a straight line. You follow that. That is a straight line. So basically just look at this here. It doesn't matter where it's drawn, if it's vertical, horizontal, a bit of an angle, but this is a straight line. So if this is 20 degrees, that opening, then this must be 160, right? 160. So I'm going to use my red pen on this one and just tell myself, okay, now I have an angle inside the triangle, right? So that was the first little piece that you needed to make sure you understood, okay? So I'll say this, arrow, supplementary, angles. So that's why the title is there, up there. I added that, right? So, good. Now what? Now we say that a ship travels south. So the ship starts here at the port, travels south, and for 2 hours at 35 kilometers an hour. If you travel 2 hours at 35 per hour, what will be your distance traveled after 2 hours? 70, right? 70, so that's 70 kilometers. So they're telling you a bit of a code language, right? They're using code and they're saying, hey, 2 times 35 kilometers per hour would be 70 kilometers traveled. So this side here is 70, right? 70 for that one right there. It then changes course. It says changes course and travels 20 degrees west of south, which is this piece of information. So sometimes if it's confusing, just look at the diagram and it tells you where the 20 goes. You travel for 3 hours at the same speed. So this side length here would be 3 times 35 kilometers per hour, which is 105 kilometers. So now you know that that side length of the triangle is 105. So this is what I mean with you will get partially labeled triangles. So you have to kind of figure out, how do I put this together? I know it's a little bit confusing at times. Just read and try your best when you come across these. So you got 105, 70, and we now have this 160 inside. It says how far is the port after 5 hours? How far is the port from the boat? They should have said, right? So they're asking you for this. This is what they're asking. Like if the boat is here now after 5 hours, because you traveled 2 hours and then 3 hours, so obviously this is your position after 5 hours. They want to know this length here, the dotted line. Okay, and this is an SAS scenario because you have side, angle, side, so we can just figure that out, no problem. So x squared is equal to this piece. I know you know how to do. Right? Oh, I'm going to run out of room here, so I'm going to do it further down here. So just scratch that. X squared is 105 squared plus 70 squared minus 2 times 105 times 70 times cos of 160. Let me just move that up a bit there. And then the next line is, so once you know how to use cosine law, this is a no-brainer. And by the way, if you made a mistake on any of these pieces that I just came up with, but you're using the formula correctly, you still get partial marks, right? So it's not that all is lost, right? So this gives you 29,738. I encourage you to try this on your calculator because I'm actually writing down all the decimals here because there's a bit of a problem here, and I will tell you what the problem is. By the way, it makes sense that the side we just found is the longest side because it's across the largest angle. There's only one obtuse angle ever in a triangle. You cannot have more than one obtuse, so that's definitely the largest, and we have the longest side there. Can you please try cosine of 160 with me? Just type in cos of 160, or some of you need to type in 160 then cos. You get a negative. You see that? See that little negative? You should all see a little negative in front of it. And that is a bit of a problem. If you're not able to type this all in one shot, then you might have a bit of a problem. And this is why. Because this negative, right, the negative value you just got here, do you remember what two negatives, if you multiply two negatives, what do they turn into? This is like grade 8, 9, positive. So if you're doing this in steps, you might be, if you don't catch that, you will be in trouble, right? So you almost automatically have to turn this into a plus when you're typing that in. So just be aware. If you're able to type this in all in one shot, you're fine. You don't even have to worry about it. The calculator does it for you. But I guess I just wanted to. So what am I saying? Well, you try this and make sure you get this, right? That's what I'm trying to say. Whatever calculator you're using, make sure you get this. Okay. The number 8 gives you all the information. There's nothing you need to fill in there, really. So I'll leave that for now. I want you to go back to 270. We're going back to sine law territory now. I told you I was going to jump back and forth. 270. No, sorry. 269. This one there. I want you to again read and see if you can fill in more information on this triangle. You can kind of apply what I just did, but now I want you to first do it yourselves, okay? Use a pencil and lightly write in where you think you can have some information in that triangle. Apologize for the pixel. So this is not 100, it's 10 degrees off the vertical. Can you try that again? Labeling. Let's see here. A photographer standing 325 feet away from the base of the Leaning Tower of Pisa. So right there, right, the photographer is 325 feet away from the base, right? So if this is my base here, the base of the tower, the photographer is right here. We're going to call this angle P, right? We're going to call this base, right? We're going to call this angle B. And we know that this distance is 325 feet. We can write that in, no problem. Okay. And here's where the typo it comes in. The tower leans 10 degrees off the vertical. What in the world are they saying there? If this is the ground, vertical would be straight up. This is vertical. Okay? Straight up at a 90 degrees. So if this is 90, it's saying that it's 10 degrees off the vertical, meaning that this line is then shifted. This is exaggerated, of course, but you're shifting it 10 degrees off of the vertical. So this is the tower here, right? So what angle do you have? If this is 90 and you move another 10 degrees, you have 100 degrees, don't you? So this angle right here is 90 plus 10. That's 100 degrees. Whoa, right? That's what was meant by that, right? So I need you to know what vertical is, right? Horizontal, think of the horizon, right? The sun sets on the horizon. Vertical is up and down, okay? There we go. So I don't know if you want to do another 90 plus 10, right? It's 100. I don't know if you want to have that here again, just in case you flip through your notes, like how did we get that 100 there? And it's basically this. You can go arrow and just explanation is there. Okay. Now what? We want the length of the tower. So we want this actual length here. Okay. Let's call this lowercase p, and this is lowercase b because it's across capital B. Okay. All right. How do I proceed? Because inside the triangle, I only have the side length and the 100 degrees here. But there's that 153 on the outside. And what do we have here? A straight line, right? Straight line. So if this is 153, you're not as excited as I am about this, but that's okay. Right? If this is 153, it's being split. So this has to be 180 minus 153. Take away the 153 and 27, right? You get 27. So the 27 is in there. And these are supplementary, right? They're supplementary. So now you have two angles and a side. Not quite cosine law, but this is the hidden pair. So PB, I don't know, let's call this up here A. I will just call that A. Angle A is going to be 180. 180 again, what's up with this whole 180? Yes, this is a straight line is 180, and all three angles on the inside of the triangle also add up to 180. So you're going to go 180 minus 100 minus 27. So 180 minus 100 That's 80 minus 27. That's 53. So now we also know this one. Okay. And we have a pair. Okay. I don't want to make this too busy here, but I'll just do that pair. Now I can use the sine law to solve that. So A here, question A, we have sine of 53. Let's get this done before we go, okay? Over 325. And we want the length of the tower, so we have to use sine of 27 over side P. Right? Cross multiply and divide. Over sine of 53. And that gives you 184.75 feet. That's the length of the tower. Let's finish this question before we go. Okay, we still have 4 minutes. B, it's asking the direct distance between the photographer and the top of the tower. So they're asking the distance from here to there. So they're asking for lowercase b. I'm going to start with the same pair that I knew already from the beginning. And now I'm just going to use sine of 100 over b. Okay? And it's the same thing. B is 325 sine of 100 divided by sine of 53. And that is 400.76 feet, which makes sense. It's the longest side, right? And C is easy. Determine the angle of elevation from the photographer to the top of the tower. Where is your angle of elevation in that triangle? This one here, right? It's between a horizontal line going up, 27 degrees. So just put C as 27 degrees. Always between the horizontal and the line going up, right? Okay, that's it. Tomorrow, expect the same kind of deal, an AC where you have to try both. What's tomorrow? Thursday. Okay. Very likely that I will mark, so that will be considered a quiz. Okay. So